The 1990s laid the foundation. Machine learning emerged, data began to grow, and AI quietly stepped out of its rule-based box. But in the 2000s, something different happened. This wasn't a decade of flashy AI headlines. There were no chatbots on the news, no robots taking over jobs, no viral breakthroughs. But beneath the surface, in labs, tech companies, and server rooms, AI was growing up. It was the silent revolution, and it changed everything. The world goes online, data starts exploding. At the turn of the millennium, the world was going digital. Fast. The internet was no longer a novelty, it was becoming infrastructure. People were sending emails, uploading photos, browsing e-commerce sites. Smartphones hadn't yet taken over, but mobile internet was coming. Social networks were emerging. Friendster, MySpace, Facebook, and every click, post, and search left behind data. Suddenly, machine learning had access to something it had never truly had before: scale. Before, researchers had to scrape together small datasets to test algorithms. Now, companies were sitting on mountains of user behavior, images, documents, and transactions. The age of big data had begun, and machine learning was ready to use it. Algorithms at work. Quiet wins behind the scenes. This wasn't the kind of AI you saw in movies. No humanoid robots, no sci-fi assistants, just math quietly powering your inbox, your shopping cart, your searches. Google used logistic regression and support vector machines to detect spam and improve search. Amazon optimized product recommendations using collaborative filtering and machine learning. Netflix fine-tuned viewing predictions with data from millions of watch histories. Banks used ML models to detect fraud in credit card transactions. Retailers predicted customer churn, optimized pricing, and forecasted demand. None of it looked like AI, but underneath, it was. These weren't deep neural networks yet. They were decision trees, ensemble models, naive Bayes classifiers, linear regressions, well-known, often interpretable models. Simple by today's standards, but powerful in practice. AI was no longer a lab experiment, it was becoming a business tool. Handling all this data required a new kind of infrastructure. In 2006, Hadoop arrived, an open-source framework for processing massive data sets across distributed computers. It helped companies crunch data at scale, even before cloud computing became mainstream. Cloud services were also beginning to reshape the landscape. Amazon Web Services, AWS, launched in 2006. Soon after, Google and Microsoft followed with cloud platforms. These gave developers on-demand access to computing power, no need for expensive local hardware. Meanwhile, the machine learning ecosystem got better. In 2007, Theano introduced GPU acceleration for neural networks. Scikit-learn, released in 2010 but built during the late 2000s, made ML accessible in Python. R and MATLAB remained strong in academia, but Python was rising fast. The toolkit was evolving. And more people, not just researchers, could now experiment with AI. In the early 2000s, neural networks were largely considered obsolete. They were seen as unreliable, computationally expensive, and difficult to train. Most AI conferences focused on statistical learning, SVMs, boosting, kernel methods. But not everyone gave up. In Toronto, Geoffrey Hinton and his team kept refining neural nets. In Montreal, Yoshua Bengio was studying how to train deep architectures. In New York, Yann LeCun continued pioneering convolutional neural networks for vision. They were few, and they were mostly ignored. Then in 2006, a breakthrough, a fast-learning algorithm for deep belief nets by Hinton, Osendero, and Tay. It showed how deep neural networks could be trained layer by layer, unsupervised at first, then fine-tuned. It wasn't flashy, it didn't make the news, but it was the first real crack in the wall. Neural networks weren't dead, they were hibernating. As the decade ended, one more crucial piece fell into place: ImageNet. Started by Fei-Fei Li and her team in 2006, ImageNet set out to build a massive labeled dataset of images, something no one had attempted at that scale. By 2009, ImageNet contained over 14 million labeled images across 20,000 categories. It was huge. But even more importantly, it was publicly available. This gave researchers something to test and prove their models on. ImageNet wasn't a headline in 2009, but it would soon become the battleground where deep learning would shine. During the late 2000s, researchers began experimenting with GPUs, graphics processing units, to speed up training. Originally designed for rendering video games, GPUs turned out to be perfect for training neural networks. They could perform thousands of mathematical operations in parallel. ideal for matrix-heavy deep learning. While still early, these GPU experiments laid the groundwork for what was coming next. In just a few years, these tools, datasets, and techniques would collide and ignite a revolution. By the end of the 2000s, AI had matured. It wasn't in the headlines, but it was in the infrastructure. Companies were investing, researchers were preparing, tools were stabilizing, the entire field was on the verge of transformation. But most people didn't know it yet. No viral apps, no viral models, no hype, just quiet progress, relentless experimentation, and a mountain of data just waiting to be understood. The 2000s didn't bring AI into the spotlight, but they did something more important. They gave it a foundation strong enough to scale. Thanks to better tools, bigger data, and persistent researchers, AI was no longer just theory. It was becoming real-world technology, ready to evolve. Want to know what happened when deep learning finally got its chance? Subscribe for the next episode, where we dive into the 2010s. Drop a comment. What tech did you use in the 2000s? Did you feel like the world was becoming smarter, or just faster? Subscribe for more.